Okay, welcome back. So this will be the last module for the week 7, and we have been looking at if you remember in the previous one, we looked at all those different engineering principles for sustainable design, and at the end I told you that we need to monetize all these factors. As an engineer or as a designer, we always look at the cost associated with any design or any process. So there are some costs which you can easily quantify, but there are some costs which is very difficult to quantify. There are some immediate costs and there are some long-term costs. So we will look at some of these economic performance indicators. So that's where we will start in this particular module. So in terms of economic performance indicator, there are always costs associated with poor environmental and societal performance can be very large. So what do we mean by that? In terms of the poor environmental, say think about if you had a certain environmental disaster. A few years back in 2009, we had this environmental problem in terms of oil spill in the Gulf of Mexico, which was this BP oil spill, and there was a huge environmental cost associated with that, because that oil spill has impacted the coastal areas across several miles in like Florida, Louisiana, Mississippi, and all those states. So similarly, right now as we speak, just like few weeks back, we had an issue of oil leakage in Chennai. So that also is a that oil leakage in Chennai we are getting a lot of environmental impact associated with that, and we don't know what will be the environmental cost associated with that. The cost is not only the cleanup cost, the cost is also the impact that these oil spills have on aquatic species, on the sea species which is present, and all in the impact on the soil. The species present in the soils, the bacteria present in the soil, are we going to lose them? Because everything which is there in that's the beauty of our nature. Each and every organism that is present in our nature has certain function. They help the nature to actually do their work. The small worms or the small microbes to bigger microbes to fish to human beings, everybody is doing something which is helping the nature. Mostly sometimes in a positive way and sometimes in a negative way, but they do help. So there are costs associated with poor environmental and societal performance. Society performance, say if people start getting sick during during Iraq war, after the war was over, and although some people may argue that war is still going on, it's never over, but say when war officially declared to be over, and after that we had the issue of several babies being born with lots of deformities in Fallujah and those other areas. The reason for being that all the warfare chemicals and other things that was used, that was actually disposed in a very unscientific manner, and that impacted the soil, the water in that particular area, and people getting exposed to those chemicals, and the pregnant woman getting exposed to those chemicals, when the baby were born, they were having certain deformities. So think about that. It's not only impacted the present generation, but impacted the future generation. And it's now the baby which is born with the deformities, he or she has to live with the deformities throughout the life. Can we really quantify that in a monetary term? Probably not. But that's a huge cost that the society has to bear. So there are, and then whatever some of the other costs which you can try to quantify, there is always a waste disposal fee, there is a permitting cost for setting up a treatment plan, there are liability costs if things there are like lawsuits, so there is a cost associated with that. We can probably put some cost associated with the wasted raw materials if you do a poor design. Wasted energy, based on the energy pricing, you can always come up with a cost associated with that. Reduced manufacturing throughput, so also consequence of waste and emissions. So some, as you can if you start thinking about it, some cost probably you can have a direct number, some costs you can come up with some number, and for certain costs, especially societal and other costs, it's very difficult to put really a number value associated with that. Then there are also costs associated with the corporate image. Think about the issues with the Nestle Maggie that we had almost a year back now, I think, and that whole image of Nestle, which got a lot of dent because of that episode. and then the money lost because of that image dent, and at the same time money now invested to get that image back, and there is also a cost associated with that. So that's and in terms of and then the corporate workers and communities, their performance. So all these things in terms of if they get sick, the performance being substandard, so there will be a cost associated because of the man-hour loss. So all these costs needs to be quantified, but how to do that? How this cost can be quantified? So there are some tools available, and there are some tools which are used for estimating environmental and societal cost and benefits. So we will try to talk about that a little bit in this particular module. There are some like you can have a time value of money. Let's say that's a traditional concept. You can have a time value of money if you have taken any engineering economics or economics course. You have done that. If you have not, you can always pick up a engineering economics book, and these some of these basic concepts are explained. So time value of money, present value, what is the present value, how much will be the payback period, what is the rate of return, other financial evaluation calculations, all those things can be done in terms of coming with some number. And there are some in terms of how to include methods for monetizing environmental cost that are hidden from normal accounting procedures. So because if you do it the normal accounting procedures, the environmental cost doesn't show up. So we have to kind of incorporate those environmental costs. So there are less tangible cost, and then and some benefits which can still be monetized. So if you are coming with a better environmental control, what are the benefits, how you can monetize them? So in traditional accounting practices, what happens is we always the traditional accounting practices, they hide the drawbacks, or we can say that they hide the environmental and societal performance cost in their balance sheet. So when you look at a balance sheet of any particular company, now in the month of March, so we are we are in the month of March, and then towards the end of March the financial year will be over, and then you will have this budget, all those different companies will have their balance sheets coming out. So just pick up any of these balance sheets and look at the balance sheet. They will have all the, this is our raw, this is the input cost, this is the output cost, this is the labor cost, this is what we paid for the salary, and all those kind of different aspects associated with that, energy usage, water usage, if they go in more detail. But never it will say that because of our activity so much of the environmental harm were done, and for that this is the cost associated with that, because it's very and that's, but we need to incorporate those costs into our calculation just to be a same level playing field. Otherwise what will happen is, when you looked at all those different engineering principles in the previous module, if you try to incorporate all these engineering principles in your company while your competitor doesn't do that, and and if you don't incorporate this environmental and societal cost, your the product which are greener may come out to be expensive, because we are looking at the holistic, we are looking at things, but the other company which they are actually cheaper, but actually if you include all the environmental cost, the cost may go up. So again, you are at benefit if you are kind of taking all these green engineering principles into account, but it may just show up not that better in terms of if you just go by the traditional way of calculating the cost, not incorporating the environmental cost as well as the societal cost. So we need to be really careful in terms of when we do the comparisons. Many companies, many organizations are there which are now actually giving consideration to all significant sources of environmental and societal cost. There are companies within India as well. The principle of the is that the costs are properly accounted, and we do the good management practices, good economic and societal performance. They actually show up to be better in terms of superior environmental and societal performance, and at the same time they do come up with lower environmental footprint and lower total cost associated with that. So in terms of how we'll go about this, so there are some terminology. We'll try to go about the environmental accounting terms. So we have always talked about accounting from just from the money point of view. So here also we are trying to put environmental aspects in a monetary term. So there are like an internal cost or private cost. What is that? Those are the costs that are borne by a facility. Cost of material and labor are example of internal cost. So it's a cost that are borne by a facility, so they are paying for it. And external cost or societal cost, on the other hand, is the cost that society or the cost to society of the facilities activity. So, for example, if there is an facility activity is leading to loss of feasible water due to a pollutant discharge in the river, in an example of external cost. Now, how will we quantify that? We probably have to come up with based on our previous cost numbers, how much fish was actually harvested from that particular area per year, and what is the market value of that fish, and from that we have to take a number of years into account, and then how much it was the total amount of money lost because of this activity. So that is only the activity, that's the money lost because that fisherman could not get the fish and sell it. So that's one aspect of the cost. The other aspect is the water is contaminated now, so water needs to be cleaned up as well. So there is a water cleanup cost associated with that. So that's again we can probably put a what is the cost of a typical water treatment plant, and for those kind of contaminants how much it will cost. We can do some literature review and we can come up with some number. But if you have to come up with a number that okay, for next 3 years or 4 years, when this river or the stream is non-usable, what is because this stream and river was used for probably for religious purposes, for some like a religious function throughout the year, or people taking bath in there, people taking a dip, or people just doing some recreational activity. But if because of this contamination, if some of those cannot be done, there is a cost associated with that, but then how to put that cost into account. So that's that there is a way to do it as well, but it gets a little bit tricky in terms of, and different people will probably interpret it in a different way. So that will be again some external cost associated with that. Often there are other type of cost, environmental fee, regulation, requirement to act on it to internalize what would be otherwise been external cost. So the facility that produces waste must pay to reduce its quantity or toxicity or pay premium. So those kind of things are over there. And so a typical management accounting system which just will go for direct material and labor, that costs are clearly and exclusively associated, and including your manufacturing overhead, sales, general administrative overhead, and then some research and development. Environmental and societal consideration can be hidden in any or another categories, but are charged most often as overhead. So we can put this money as an overhead money if we can as a part of the cost that that goes in there. So what we do, even the direct environmental cost which could be assigned to a particular process or product or activity, such as waste disposal, usually what it is done, they are lumped together in a facility wise. So we put everything together as a one cost. And say if this is often done because practices that you will use a single waste disposal company to manage all of your waste. So and then there are lots of you have to fill a form. So you have to fill up lots of forms for environmental compliances. So those forms will be certain man hours is required, so there will be a cost associated with the man hour, and then that's all usually hidden in the overhead category. So it's so because environmental and societal costs are not traditionally allotted to a particular activity, some of the benefits of green engineering projects are it gets masked. You don't see the benefit directly because although you have applied certain green engineering principles, you have improved part of the process. But since the cost associated with managing the wastewater and other stuff, that goes as I would say that doesn't go so that doesn't get attached to that one particular process or which you have improved upon. You are looking at the entire cost, entire processes. So whatever the benefit you are getting in terms of improving that particular process, that doesn't really show up very clearly. The benefits is not seen very clearly because you are not you are looking at the whole thing. You are looking at the total processes together in terms of its cost. So the benefits of one particular process, it does not get reflected very well in terms of the benefit. So you go for what is known as the full cost accounting type of managerial accounting. You can allot all the many costs as possible. Look at for product line, process, service, activity, It does not focus particularly on environmental and societal, but it look at it, since it takes account all the different costs associated with that. It does take, so if you improve upon waste management, if you improve upon societal impacts, it does show up. It does gives a better idea of the true cost. So you should go for the full cost accounting. Then there are activity based costing, which is like it's similar to full cost accounting, but you are specific, look at specific measures or activity. For example, if you look at activity based costing, the cost of generating a particular kind of waste per pound of production might be measured, and then we can try to reduce the cost being produced, and then we'll say how much money was saved accordingly. So that's like in terms of different types of like I would say parameters or different types of we talked about this different terminology used for these. Now we'll try to look at how we try to estimate some of these environmental costs, and which I kind of told you some of this example already. So not all of the environmental costs are captured in traditional accounting. So what happens is there are some measures of environmental and societal costs are available, but among industry sectors. Among the easiest environmental costs to track are the costs associated with treating emission and disposal of waste, because we can quantify that, how much money required to dispose the waste. Again, disposal of waste, if you just think about the waste, how much was the waste disposal fee that was charged, that is one cost. But since you are producing this waste and the waste is being dumped into the landfill, what will be the landfills, leachate being produced from the landfill gas is being produced, then there are some costs associated with the leachate treatment, there are some costs associated with that landfill gas treatment, and you are taking a land and you are making it a landfill, which you are reducing the cost of the area nearby, because nobody wants to have landfill in their backyard. So the property prices near the landfill usually have a tendency to go down. So there is a drawback of having a landfill there, but though there is a cost factor. And then since say landfill, if something happens in future, what would be the problem associated with that? So all those things are there. So not all of these environmental costs are captured in traditional accounting and capital budgeting practices. So but some are available. So that gives a rough indication of magnitude of cost and the variation of those costs among industry sectors. Among the easiest environmental costs to track is what we talked about, the cost associated with treating emission and disposing of the waste. These expenditures are not distributed uniformly among industry sectors, so because they are usually lumped together. So what the different sectors, we'll look at some of the examples in the next slide. The different sectors such as petroleum refining or chemical manufacturing, they spend higher fraction of their net sales in pollution abatement than do the other industrial sectors. So minimizing cost by preventing waste will be far more a strategic issue than so in this particular type of sectors. As you can see in this particular table, you can on the left you look at this petroleum, primary metals, paper, chemical manufacturing, stone products, lumber, leather products, fabricated materials. So all these different types of industry sectors have been shown over here. And then we have this what is the pollution expenditure as percent of sales. So as you can see, as we go down, this has been arranged in with the more pollution control expenditure being on top, while the numbers as you go down you see less and less numbers being there. So petroleum industry, primary metal, paper mills, chemical manufacturing, they are kind of doing nearly they spend a higher chunk percentage wise as percentage of the sale. The pollution control expenditure, and then the pollution as per at the percentage of the value addition, you see that as well. The value addition is then pollution control capital expenditure as percentage of total capital expenditure. So based on the total capital expenditure, nearly 26% goes in pollution control for petroleum industry, 12% in primary metals, the 13.8 to 17.2%. These are the two different sources. Nearly, so that's it goes into the pollution control capital. So there are like a good amount of money that has been invested on that. So then if you want to calculate what is the potential pollution control cost for the greenhouse gas, We can estimate the control cost for greenhouse gas as a percentage of the sales. We can do that percentage of sales revenue. Say if you assume that for electricity generating unit, which is shown as the EGU over here, uses coal as a fuel and converts the heat of combustion of the coal into electricity. And as we have seen in the very first module, or maybe the first or second module, that these processes are very low efficiency. So we are looking at a 35% efficiency. The heating value of coal is given to us like 10,000 BTU per pounds. Coal is 85% carbon. Carbon costs $20 per ton to capture and sequester. Electricity can be sold at 10 cents per kilowatt hour. So if these are the values which is provided to us, if we want to find out what is the in terms of we can look at in terms of the different fraction, like what is the percentage in terms of the sales revenue and other stuff. So electricity generated per ton of carbon, based on the data that is available to us, we can find out it's a 1 ton of carbon, 85%, coal is 85%. So 1 ton coal means how much carbon. Then carbon, this ton is British ton, which is used in US and other places. So it's 2,000 pounds per 1 ton. Then we know BTU per pound for coal, and we also know that 1 kilowatt hour is just conversion of BTU to kilowatt hour. Then 35% efficiency. So from 1 ton of per ton of carbon, we get 2,415 kilowatt hour. Now price is $20 per ton to capture and sequester. So control cost is $20 per ton. So for this much kilowatt hour, that's the control cost. This much generation leads to 241 electricity cell. We can multiply 10 cents multiplied by 2415, that gives you $241 in electrical cell. So if you look at the control cost as a percentage of the cell, total cell will be $241. Control cost is $20. So 20 divided by 241, that's around 8%. So that's kind of gives you, so we can do this kind of calculation. So and if you, some other example in terms of one particular refinery, if you look at the different categories of cost, then if you look at the based on the annual non-crude operating cost, waste treatment nearly 5%, and maintenance for 3.3%, product requirement 3%, depreciation, administration, sulfur recovery, total cost is around 22%. So it's 22% kind of goes into the environmental cost at a particular refinery. So this is again just an example to give you an idea. So this is in terms of different types of cost, how much it kind of ends up over there. Another example here, total is 19.1%. Earlier, if you look at the refinery, was around 22%. This DuPont chemical manufacturing facility nearly 20%. So they're not that different, around around 10% plus and minus. So here again, the depreciation, operation, contract waste disposal, utilities, salary, maintenance, engineering services. So all those aspects has been included over there. So so there was always a need for having a framework for evaluating environmental cost. So as you saw from the examples and the discussion so far, there are ways to do it, but there are, as you can say, that things can go subjective. So with the way I look at certain aspect and the way you look at certain aspect may be different, and then we will end up kind of giving a different kind of cost numbers associated with that. So it's engineering projects. So we have this is generally we don't take engineering unless they are financially justifiable, and project is designed to improve environmental and societal performance. Projects resulting in improved environmental and societal performance are frequently profitable, which we have been found that, which results in however, potential profitability of environmental and societal projects is difficult to assess. So like how they will be, and it is common for many of the financial benefits to be neglected when project is analyzed. So that's why we have to have a better understanding of these costs and promote sustainable engineering. So what we do, how we go about this total cost assessment methodology, and we go for tier 1. So for the cost normally captured by engineering economic calculation, Then we go to the tier 2 cost, which is the administrative and regulatory environmental cost, not normally assigned. Then liability cost in tier 3. Tier 4 takes into cost and benefits internal to a company associated with improved environmental and societal performance. Then tier 5 looks at cost and benefit external to the company. So all these different costs, as much as possible, is quantified, and then you add them up to get the total cost associated with that. And they are usually, what kind of cost we are looking at? We are looking at the capital equipment, material, labor, supplies, utility, structure, salvage values, and all that. So, and as I said earlier, many times the environmental cost is charged to the overhead, which includes the off-site waste management charges, waste treatment equipment, operating expense, filling of the papers, permits, tracking samples, sample report forms, conducting waste emission inventory, sampling. So all these different aspects that you see over here: inspecting hazardous waste, sampling stormwater, making chemical usage report. So any each and again, these are like a long list, very exhaustive list, but there still could be some of the other aspect which is not being included here. So for each one of these, when the environmental cost, there is a cost associated with that, but usually we lump them all together and put it as part of that 25% or 30% overhead cost that we have. In terms of the liability cost, that includes compliance obligation. If you have to do remediation, that your obligation is there, fines, penalties. And then if you do anything to the private parties for personal injury, property damage, economic loss, there could be punitive damages, natural resource damages. So all these things are liability cost associated with any activity. So let's look at this particular like a chart, and then we'll kind of end this particular module. So in terms of the life cycle stages, which we kind of saw earlier as well: raw material extraction, processing, manufacturing, use, and disposal. For each one of these, material and energy input is there. For each one of that, we have some waste being produced, and we can use pollution control to reduce the waste being produced. And then you have the impact that is coming from each one, and then you have these are called midpoint, and then you have a like an end point, which is a human health and ecosystem damage. So this whole thing, if you remember, this is nothing else but what we talked about as a step-by-step methodology for life cycle analysis. So again, all this stuff that we have been talking together, how they relate to this life cycle stuff. So that's we have these are the different life cycle stages. So having this life cycle thinking helps us to come up with this better environmental performance indicator. So you can look at the emission, you can look at the environmental transport transformation, midpoint damage, endpoint damage, and all the what are the environmental cause and effect and all that. So we will being said all these things so far. In the next module, we'll be kind of looking at this life cycle impact assessment, which we have already done earlier, but again it's will be kind of a recap, and then we'll look at some of those calculation of how it is done. And then we will from the next module we'll get into week 8, which is the last week of the course, and so that will look at again kind of recap your life cycle the way we started it, and then we'll have some case studies from different research projects that I've worked on, some of the industrial projects as well. So with that, let's close this particular module, and I will see you again in the next week module, which will be your last week of this course. I hope you're enjoying this course. Thank you, and see you again.